Hello, astronomy meteorology students. It's Mr. Johnson here. I want to take a minute and give you a few brief notes over some basic characteristics of the atmosphere. We will be using this basic knowledge for the rest of the year that we're together. And so I just wanted to explain them now. Hopefully it won't take too long. I encourage you to take notes on it on a Chromebook or paper. That's up to you. So let's start with the troposphere. Tropos means change. And when we're talking about change, we're talking about weather. So I want you to think for a minute to yourself, what is the weather like right now? If I were to actually ask you that question and have you respond, what would you tell me? Would it be maybe that it's sunny out or with clouds? Maybe you'd talk about wind. Well, what the weather really is the conditions in an area at a particular time. And it can be as general as a city. It can be as specific as, what the weather is like at my house right now. But it is conditions in that atmosphere at that time and place. It includes characteristics like the temperature, the air temperature. It includes things like wind speed and where the wind is coming from, the moisture content of the air. And it'll even have to do with, combining a few of these. So, for example, we might combine temperature with the moisture in the air. So if it's really hot and really humid, then we have, you might hear the report of heat index, which typically means it feels warmer, and we'll talk about why that is a little bit later. The key here is the weather can and does change often and quickly. We know this in South Dakota to be especially true. It can be really, really nice and warm and sunny one day, and in a matter of an hour or two, change pretty drastically. And we've even gone from really warm days to a snow day, in a day or two. So the difference between that and climate has to do with the length of time that we're looking. So weather is a day-to-day process. It's, what is the weather doing now outside, as opposed to the climate is a really long range. So climate scientists, they will use an average out 30 years worth of data. It's a lot of data that they average out. And as they get new data, as new data comes in and gets recorded, it's added to that average, and the oldest measurements are sort of dropped off. And that's how we get the climate. Climates you may have heard of would be things like tropical or polar. We live in a climate called temperate, which has to do with seasons. To discuss a little bit of the properties of the atmosphere, we're going to be going over three different ones today: air pressure, temperature, and humidity. You've watched Ed puzzles over air pressure, and you will have at least one or two over humidity, not so much on temperature. But let's dive into it here. So when it comes to atmospheric pressure, that pressure comes because the atmosphere has mass, and we can demonstrate this pretty easily. You can fill a balloon and measure the mass or the weight before and after you fill it. We would, if we were in class, do a few demonstrations of this, but we're not going to, obviously, because we're not in class, unfortunately. You could take two balloons and blow them up with air and put them on sort of a teeter-totter and release the air from one of them, and you would see that the one with air still in it, that is heavier, and so that end sinks. You can even cover cover the majority of a ruler with a really big but thin piece of paper on a desk, and you'll find that if you hit the ruler that's hanging off of the desk, with a kind of a solid slap, that it would not be able to move that paper off of the table because of all of the air pressure pushing down on a large surface of that paper. That little ruler would not be able to move it. Obviously, you can move it if you apply constant pressure, but that's different. A lot of that mass is really close to the Earth. And really, when we're talking about air pressure, we're talking about how much pressure is being put on by the weight of the atmosphere above it. So the further up we get, the less atmosphere is above it, so the less air pressure there is. We measure this in millibars. There's another way we can measure air pressure too, and we'll talk about that in a minute. It is directly related to density. So if you think about our layers of the atmosphere, as we go higher up into the atmosphere, the air thins out. So it becomes less dense. The area where the air is the most dense is close to Earth. You can see it in this graph here. So the air pressure is going to be the highest where the air density is the highest. And both of those would be at ground level. As you increase in altitude or elevation, the air will thin out, which means that there's less air pressure. And you can actually feel this if you actually go up into the mountains. The air will feel lighter. It will feel thinner. Even higher up in an airplane, for example, they will pressurize the cabin because you're high enough in the air that the air is thin and there's not very much pressure. And so to maintain, normalcy in the body and normalcy in actually the amount of oxygen we're getting, they pressurize the cabin. The key here is with an increase in altitude, you have an increase in air pressure. Or excuse me, an increase in altitude means that there is less air density, which means that the pressure is decreased. To measure atmospheric pressure, we use an instrument called a barometer. And what this does is this measures the amount of pressure or weight of that atmosphere over a particular area. And there are two types of barometers that we'll learn about. One type is the liquid barometer. Historically, mercury was used. We don't use that now for health reasons. The basic concept of a liquid barometer is that the atmosphere will push down on a liquid in sort of a disc here in a tray, and that pressure will cause the liquid to rise up a tube. And so the higher the air pressure, it would push down more, and this then would climb higher through the tube. Lower air pressure would mean that the weight of that liquid would be able to drop down the tube, raising higher in this glass dish at the bottom, and then this level would be lower. This is the historic reason why we measure, or why barometers are the scale on a barometer is the mmHg. That stands for millimeters of mercury, which goes back to this mercury barometer. There is another thing just to make you aware, something called an atmosphere. Sometimes we refer to the number of atmospheres when we're talking about measurements of air pressure. What's used now would be an aneroid barometer, and then there's also digital barometers too, which is obviously the most recent. So aneroid barometers is most commonly used, doesn't contain mercury. There's a container essentially that's sealed, and different air pressures will cause it to change shapes. And as it kind of changes shapes, going from more rounded to more flat with increased air pressure, that causes this little needle to move along a scale telling you what the air pressure is. We won't watch that video. And the key here is that the layers of the atmosphere are not decided based on pressure, because pressure pretty consistently becomes lower at higher altitudes. Instead, layers of the atmosphere are determined by sharp changes or definite changes in temperature. And we'll talk about temperature in the next video.